Welcome to A-Level and AP Physics. In today's class, we will discuss how to sketch reflection and refraction diagrams for CIE IGCSE Physics by solving past paper questions. For this question, direction of travel of wavefronts is shown by this incident ray and the surface in this case is mirror. But if you look at figure 7.2, in this case, direction of travel of wavefronts is also shown by incident ray. The surface in this case, this is glass block. Question is asking us on figure 7.1 and on figure 7.2 to draw wavefronts to show what happens after the waves strike the surface. We need to understand what will happen to this incident ray and wavefronts after these waves strike the surface. So this is plane mirror. In this case, simply we can write down reflection will take place and incident ray means these incident wavefronts, they will be reflected. So this is simply reflection. But if you look at the second one, the second surface is glass block. In this case, wavefront will be refracted. So this is example of refraction, means in this case, reflection will take place. First of all, let's try to draw reflected wavefronts on figure 7.1. In order to draw reflected wavefronts, we will follow these steps. First step, we will draw normal to the surface, means normal to this surface. Second step, we will draw reflected ray, and third step, we will draw wavefronts at an angle of 90 degrees to the reflected ray. Now let's try to draw normal to the surface, means do first step. Let me place protractor here. So our protractor is here. We can find out this angle. First of all, let me find out the angle. If you look at this angle of this incident ray with normal, means with normal, this angle is 70 degrees. So our reflected ray also must have angle of 70 degree with normal. So let me draw normal first of all. I will use this solid line, yellow color solid line, but in your final exam you need to use dotted line instead of solid line. So this is normal and this is at angle of 90 degrees to the surface. Next step, we need to draw reflected ray, and that one has to be at the same angle as the angle of incident ray with normal, and that angle is 70 degrees. So here angle is 70 degrees, means from this normal 90 degrees. Now we have to draw the line here, so we will just draw this line here. So this is our reflected ray. Next step, we need to draw wavefronts. We need to move this protractor. We need to align this one with our reflected ray, so you can place like this and you can draw the first wave front. Let me draw the first wave front. So this will be over first wavefront. So this is how you can draw. Then you can move this back, and you need to consider the distance between wavefronts has to be the same as this distance between these incident wavefronts, because the wave is the same and it is in the same medium. So the speed of the wave is the same and wavelength of the wave also is the same. Now we can draw our second wavefront here. So this will be our second wavefront. Distance, you have to be careful with distance. This is second wavefront. We can move this back and we can draw next wavefront. So this will be our next wavefront. Distance has to be the same between wavefronts. So this is our next wavefront. We can move this back and we can draw again the next wavefront. So this one is our next wavefront. Let's draw the last one. So the last one we can draw here. So this is the last wavefront like this. So this is how you can draw reflected wavefronts. Draw the arrow as well. So let me draw the arrow. So arrow is must to show direction of reflected ray. This is for figure 7.1. For the second part, we need to draw refracted wavefronts on figure 7.2, and we will follow these steps. Means first of all, we will draw normal to the surface, then we will draw refracted ray, and finally we will draw wavefronts at an angle of 90 degrees to the refracted ray. First of all, normal to the surface. Again, I will use solid line for normal, but in your exam you need to use dotted line for normal. So this is over normal line. As you can see here, this is normal to this surface. This is our step 1, and for the second step we need to draw refracted ray. As the wave is traveling from less dense medium to optically denser medium, wave will bend towards normal. So we have to draw something like that. So this will be over refracted ray. Third step. For the third step, we need to draw wavefronts at an angle of 90 degree to refracted ray. Let me align this one with the refracted ray. So first of all, you need to align your protractor with the refracted ray. So now you need to draw your wavefront. So we can see here, let's say draw from here. So here, so we can draw our first wavefront. So this is over first wavefront, and also the distance between these wavefronts has to be shorter than the distance between incident wavefronts. You also need to keep that in your mind. So the second one we can draw here. So this is second wavefront. This is how we can draw the wavefronts. Now after drawing these wavefronts, we also need to draw direction of a refracted ray. You can use this small arrow here. So this is direction of refracted ray. For question number 7, it is given to us that sound from a loudspeaker is traveling in air and it is moving towards a solid wall. So this one is solid wall, and this is sound that is traveling to the solid wall. Direction of travel means this is our incident ray, and these lines, they are representing compressions, mean these are the wave fronts. For this question, we need to complete figure 7.1 to show the positions of 3 compressions, means 3 wave fronts of the reflected sound wave. So this question is just about reflection. For this question, we will also follow very similar steps. So let me explain to you steps. First of all, first step we will extend the incident ray, mean we will extend this one to the wall. Then we will draw normal to the surface, and then we will draw reflected ray. Finally, we will draw reflected wavefronts at an angle of 90 degrees to the reflected ray. So these 4 steps we will follow. So let's start from step 1. Step 1, simply we need to extend this line. So I will use red color for this one to extend this line. This is how you can extend this incident ray. So this is how we can extend. So this is our step 1. Second step, we need to draw normal to the surface, and for that purpose we need protractor. So let me grab protractor here. This is our protractor. We need to align this one with the surface. So let me align this with the surface. So here we can place this. So align this with the wall, means with the surface, and we need to draw the normal line. So this is our normal, and this is at angle of 90 degrees to the surface. So this is normal line. So we can draw this our normal line. For third step, we need to draw reflected ray. We need protractor again. So let me place protractor here. So this is how you need to place protractor. You need to find out the angle of incidence. angle of incidence we need to find out. Now if you look at angle of incidence, this is 30 degrees, 90, 60, 30 degrees. So reflected ray means angle of reflection also has to be 30 degrees. So 90, 120, so this angle of reflection, this is 30 degrees. Now simply we need to draw the line. So we just draw over reflected ray. From here we can draw reflected ray. So this is over reflected ray. This is how we can draw. Next step, we need to draw reflected wavefronts. For that purpose, we need to align our protractor again with reflected ray. So we can align this one like this. And now we can draw wavefronts. So let's draw first wavefront from here. Draw our first wavefront from here. We can extend this one a little bit to this point. So this is our first wavefront. We can also draw the second one, but the distance between wavefront has to be the same. So we have to be careful with distance. So we can draw our second wavefront from here. So distance is almost same. So this is right one. So we can draw from here. For the third one, we can again place over protractor here and we can draw the third wavefront. Third wavefront, the distance has to be the same. So from here we can draw third wavefront. We also need to draw arrow on reflected ray. So this is arrow for reflected ray. This is very important. So we can also draw arrow here. This is how you need to answer this question. Welcome to A-Level and AP Physics. In today's lesson, we will discuss how to sketch refraction, refraction and diffraction diagrams for CIE IGCSE Physics exam. In the last video, we have discussed some past paper questions on reflection and refraction in part 01. If you haven't watched that video, you can search the channel for reflection and refraction 01. In this video, we will do more challenging questions from past paper based on reflection, refraction and diffraction diagrams. So you can have clear understanding how to sketch this type of diagrams. Our first question is about reflection. It is also given very clear in this question by reflection at the surface of the water. For this question on figure 6.1, we need to draw the reflected rays and we need to complete the diagram to locate the position of the image. We also need to label the position of the image using letter I. Now let me explain to you how to draw reflected rays. For this purpose, the first step we will follow, this step is we need to draw two normals to the surface, and in second step we will draw reflected rays and then we will extend reflected rays to locate the image position, and finally we will also label position of the image with letter I. First of all, let's draw normal. First normal we have to draw at this point. So simply you can draw your normal line like this. So this is our first normal. So we can also adjust. So this is about 90 degrees now. Let's draw second normal. We can draw second normal at this point. So this is our second normal. As the normal, it has to be a dotted line, and with no need to draw too long, we can make it a little bit shorter. So these are two normal lines. The next step what we need to do is we need to draw reflected rays. For reflected rays, again we need protractor, so we can place our protractor here. We need to measure angle of incidence. In this case, angle of incidence angle of incidence. So angle of incidence is around 47 because angle of incidence is from normal. So this is around 47. This is around 47. So here, so this is our angle of reflection. Angle of reflection is this. We need to simply draw the reflected ray. So this is our reflected ray. This is how we can draw. We can also extend this one because we need to extend to locate image. So simply we can extend. So we no need to redraw again. So this is our reflected ray. Now we need to draw another reflected ray at this point. Again, we need to find out the angle of incidence for the second incident ray. And this angle is 28. So it simply means that 62 angle of incidence is 62. So we will go to this side. So angle of incidence has to be 62. This is around 62. Again, we have to draw our reflected ray and we will extend this. This is our second reflected ray. Let me a little bit adjust. This is second reflected ray. We can remove this and we can draw small arrows. So in this case, our reflected ray means this is arrows important. You have to draw to show direction of reflected ray. Image is located here, so we can use letter I for this one to label this. Extended line should be dotted line, so we make our extended line as dotted line. So like this, we can make this dotted line. So the best way to draw is this has to be dotted line. This is how we can draw, and that's all what you need to do for this question. For part B, it is given to us that an observer sees the image of cube produced by refraction at the surface of the water. Our object is here. This is object cube. An image is formed by refraction. By refraction, it means this is about refraction. This question is asking us on figure 6.2. We need to draw possible refracted rays. Possible, it means we no need to worry a lot about angles, and complete the diagram to locate a possible position of the image and label the position of the image using letter J. It is also given to us you don't need to calculate any angles, so we no need to worry about angles a lot. First of all, we need to draw the normal line. So let's draw normal line here. So this is our normal, quite good one. We can use protractor, but if you have some experience, you can simply just draw like this. So this is our second normal. We can also make them dotted, so normal has to be a dotted line, so we can make them dotted lines. So like this, we can make them dotted lines. We need to draw refracted rays. From here, we can draw our refracted ray. If there is a no change in medium, this will go in a straight line like this. But in this case, there is a change in medium, so it will bend away from normal because waves are moving from denser to optically less dense medium, so it will bend away from normal. So we can draw our refracted ray like this. If you look at these two angle of incidence, this angle of incidence is smaller as compared with this angle of incidence. It means this angle of refraction also will be greater than this angle of refraction. So let me draw a ray here now, refracted ray. So this will bend more. So like this, we can draw. We need to extend these refracted rays. We can extend like this. So we can extend like this. These extended lines, they have to be dotted. So we can also make them dotted like this. Our image in this case will be located here. So this is position of the image, and for this one we have to use letter J. So this is image. Only one thing is missing now, that is direction of refracted rays. We must draw arrow. So this is how we can draw. For part C, two identical waves moving towards the boundary at an angle. It is given there are two identical waves, means wave A and wave B. For this question, we need to draw on figure 6.2 remainder of the waves A and B and plus two previous waves which reached the shallow water. We also need to use a ruler so we can draw in a proper way. Now, first of all, let's try to understand the speed of wave in deep water as compared with speed of waves in shallow water. Speed of waves in deep water is faster as compared with speed of waves in shallow water. Now, question is that why speed is faster in deep water? The speed of waves is faster in deep water because there is less friction. So we can say less friction from ground. From ground, so you can say from the seabed, from ground. So that's the reason the speed of waves in deep water is faster. We can also observe this one in everyday life. If you go to the seaside and you observe the waves coming from the deep sea, you will see the speed is much faster. As those waves they reach the seaside, they slow down. Why they slow down? Because the water near seaside is shallow water and there is more friction from the ground. We will discuss this question in detail so you can have very good idea about this type of questions, and in future you can draw with confidence. I will explain this question in detail, but the remaining question we will just follow shortcut methods. In order to draw refracted rays, we need to extend this ray. So we will extend this ray. So this is our ray. Now the next step, we need to draw normal to the surface. For that purpose, we will need protractor, but you can also draw without protractor if you are very confident. If not, we can simply use protractor. So this is how we need to align. We will align our protractor here and we will draw normal line. We will draw normal from here. So this is normal to the surface. We can make it a little bit short. We don't need to draw too long. So this is our normal line. Next, we need to draw refracted ray, refracted. So let me change color. If there is no change in medium, this ray will just go in a straight line, waves go in a straight line. But as there is a change in medium, so this will bend towards normal because shallow water is optically denser medium, so it will bend like this. This is our refracted ray. Now we need to draw wavefronts. We will change color and we will draw the wavefronts. For the wavefronts, we need to align this. Wavefronts has to be at angle of 90 degrees to the rays. So we will align first of all this protractor like this. We can also move like this, so it will be easier to draw. We need to draw complete these waves. So this is our refracted ray in shallow water. We can extend this more and we can draw next refracted ray. This is how we can draw our wavefronts, but we also need to draw arrow on refracted ray. So this is our refracted ray. This is how we need to draw the arrow. That's all for this question. Let's try to understand a little bit more about refraction with the help of this animation. If you watch this animation carefully, you will see that this medium is optically less dense and this medium is optically denser. That's the reason when the waves pass from less dense medium to optically denser medium, they are refracted towards surface. You can see from here, so these ends, if you observe these ends, you can see they are refracted towards boundary, and we will use this idea to answer next questions. For this question, it is given to us that waves are coming from deep water and they're moving towards shallow water. It is also given to us that in shallow water, the waves are traveling more slowly as compared with deep water. So it simply means that deep water is optically less dense medium and shallow water is optically denser medium. For this question, we need to complete figure 5.2 to show possible positions of the 5 wavefronts in the shallow water. Now we need to understand the waves are entering optically denser medium, so they will be refracted towards normal, means they will bend towards normal. So we can draw the wavefronts like this. This is our first wavefront, and the second wavefront we can draw here. The distance also between wavefronts will be shorter, so like this we can draw. We need to keep the same distance between wavefronts, and also they have to be parallel, so this point you need to understand. The last one, this is how we can draw. This is how we can draw the 5 wavefronts in shallow water. If we want to draw the refracted ray will be somewhat like this. This is refracted ray. We can also draw the arrow on this. So this is arrow. So you can see this angle is 90 degree between ray and wavefronts. In this question, waves are coming from shallow region and they're moving towards deep region. For this question, we need to complete the diagram to show possible positions of the 5 wavefronts in deep water. Now we need to understand waves are coming from optically denser medium to optically less dense medium. So they will bend away from normal, or you can say they will refract away from surface. Only this point we have to keep in mind, and we can draw refracted wavefronts. Refracted away. So this is how we can draw our first wavefront, refracted away, and we can draw the second wavefront. They have to be parallel and the distance between them has to be greater. So these are few points we have to keep in mind when we draw these wavefronts. They have to be parallel and the distance between them has to be longer as compared with the distance between wavefronts in shallow region. So this is how we can draw. So the last one we can draw like this. So this is how we need to draw wavefronts in deep water. If we want to draw refracted ray, we can also draw at an angle of 90 degrees to these wavefronts, somewhat like this. We can also add arrow, so this will be the arrow, and you can see this angle is about 90 degrees. This is how you need to draw wavefronts in deep region. Welcome to A-Level and AP Physics. In today's lesson, we will discuss how to sketch diffraction diagrams for CIE IGCSE Physics exam by solving challenging past paper questions. For part A, it is given that wavefronts are approaching a gap in a barrier. So this is the gap and this is the barrier. This is the barrier. So it is written here. This is barrier. For this question on figure 6.1, we need to draw at least 3 wavefronts to the right of the barrier. Means 3 wavefronts we have to draw to the right of the barrier. Means on this side we need to draw. This question is about diffraction. Means about spreading of the waves when they pass through a gap. Next thing, we need to understand the distance between these 2 wavefronts, and this distance is equal to the wavelength. The size of this gap is almost equal to wavelength. So it simply means that in this case maximum diffraction, and we need to draw circular wavefronts. In order to draw circular wavefronts, we need to locate the center of this gap. So the center of gap is almost here. So at this point, so we can mark the center of the gap. So this is about center of gap. Now we need to use compass to draw the circular wavefronts. Place your compass and open this. So you see, if I open this compass, we need to find this. The radius of the circle has to be equal to this. We can draw our first circular wavefront. So this is our first circular wavefront. Again, we need to open this or compass. Open this one equal to the radius, equal to the radius from the center to the second wavefront, and we need to draw our second circular wavefront. So this is our second circular wavefront. In order to draw the third one, we need to again open compass, and now this time up to the third wavefront from the center. So up to third wavefront. So this is now again we have to draw our third wavefront. This is how we can draw circular wavefronts. We also need to be very careful with the distance. Means the distance between these wavefronts and the distance between these wavefronts has to be the same. This has to be the same because same type of wave in the same medium. So this distance has to be equal to this distance. That's all what we need to do for this question, but we can a little bit adjust to make it look better. We can clean this part. So this is how you need to draw. For part B in figure 6.2, circular wavefronts from a point source in a tank of water strike a straight barrier. So this is straight barrier, this black line, you can see this is straight barrier. Waves are coming from this point source, so this is over point source. The reflected wavefronts seem to come from a single point. If you look at these 5 wavefronts, first, second, third, fourth and fifth. Fourth and fifth, they reach the barrier and they are reflected from the barrier. So it simply means that for wavefront number 4 and 5, we need to draw reflected wavefronts. On figure 6.2, we need to mark a dot to show the position of this point, and we need to label that point using letter capital C. For second part, we need to draw the reflected circular wavefronts. First of all, let's try to answer part 1. For part 1, we need to locate the position of the image, and that one has to be at the same distance from the barrier as the point source. If we place our scale here, you can see the distance from the barrier of the point source is about 1.8. So we will move our scale up, and the distance here of the image location also has to be 1.8. So this is about 1.8. So we can mark the point here. So this is location of the image, or in the question they're asking you about that single point from where wavefronts are coming, reflected wavefronts are coming. So we can mark this point here. So that's all what we need to do. But for this one, we also need to use capital letter C. So you can also label this one using capital C. Let's move on to second part. For the second part, we need to draw reflected circular wavefronts. Only these two wavefronts are reflected. So only for this one and for this one, we need to draw two reflected wavefronts. For that purpose, we need compass. So you need to place your compass at this point. So we will place our compass here, and we can move this one, and we can open, you see here. Now at this point, this is our reflected wavefront. So you see, you can draw like this. So this is for reflected wavefronts. We can draw like this. Now we need to open this more, and we need to draw the next wavefront. So we can open this more. Now you can see here. So this is our second wavefront. That's all. This is how you need to draw these two reflected wavefronts. Welcome to A-Level and AP Physics. In this lesson, we will discuss how to sketch lens and mirror diagrams for CIE IGCSE Physics by solving tricky past paper questions. This question is about reflection, and we can answer this question using different methods. In order to answer this question, we will not use our conventional method of using protractor and measuring angles. We will simply use a scale, and by measuring distance, we will sketch the diagram. Let me explain to you how to use scale to answer this question. First of all, you need to place your scale here. You need to find the distance of the object from the mirror. You also need to find the distance of the image from the mirror. Distance of object and image from the mirror has to be same. So you can see from here the distance of object from mirror is around 3.8 centimeters. So the total distance of object and mirror, that will be equal to 7.6 centimeters. So simply we can mark here 7.6 centimeters. So this is location of image. Now we can remove scale, and we need to draw two reflected and extended lines. We will draw our first extension, and this is also reflected ray, first reflected ray. Next we need to draw another reflected ray, also the extended line. This is how we can draw. We need to use two normal, means we need to sketch two normals. We will sketch first normal here. We can move little up, so this is our normal at this point, and the second normal we can draw here. So this is our second normal. Now for reflected rays, we also need to use arrows, so we can use arrows. So this is telling us these are reflected rays. Extended lines has to be dotted line, so we can make them dotted lines like this. So these are our dotted lines. Image location we have to mark. Our image will form here. We need to use letter capital I. So we can write down letter capital I here. This question is also about reflection. For this question, we have a lamp and a plane mirror is placed at this location. Question is asking us on figure 8.1, we need to draw two rays from the center of the lamp that strike the mirror. Use these rays to locate the image and label the image using letter I. So first of all, we need to draw incident rays from the center of this lamp. So let's say this is our first incident ray. Now we need to draw the second one. So second one we will also take from the center of the lamp. Let's say this is our second incident ray. We have the first one and we have the second one. Next we need to draw normal to these incident rays. So this is our first normal, we can draw like this, and our second normal we can draw here. So these are two normals. Now we need to find the angle of incidence and angle of incidence for the first one and also for the second one. Now let's place over protractor here, and we can find the angle of incidence for the first ray. Angle of incidence for the first ray, this is 17 degrees. We have to repeat this one for reflection as well. So this also has to be 17. So this is angle of reflection. We will use different color. Let me use the pink color for reflected rays. We will extend this one because we also need to draw extended lines. So I will extend this one like this. You can little adjust. So this is our reflected line. Now again we need to find out the angle of incidence for the second incident ray. For the second incident ray, our angle is 10 degrees, 20, and this is 30 degrees. So this is 32 degrees. If you look at this, 10, 20, 30, and this is 32. So we can also go to other side. So the angle of refraction also has to be 32 degrees. So this is 32 degrees. We need to draw our second reflected ray. We will extend this one as well. So this is our second reflected ray. We can little adjust. This is at this point image will form here. We can also use for image letter capital I, so the image will form here. So this is capital I, image location. We don't need protractor, we can just move this away, but we need to draw arrows on incident rays. So this is arrow on incident ray on these two incident rays. Also we need to draw arrows on reflected rays. So arrow on reflected ray. So these two arrows we can draw like this. Extended lines has to be dotted, so we can make them dotted lines. So that's all what we have to do for this question. This question is about refraction. You can see one convex lens, or you can say converging lens, is placed here, and its two principal foci f1 and f2 also labeled here. Object is placed at this point. This is our object. We need to complete the diagram to locate the image of the tip of the object. Draw in the whole image means we need to draw the whole image, and we need to use letter I to label image. This is very straightforward question. We need to use two standard rays as it is mentioned here. Draw two rays. We will draw one ray from the tip of the object and parallel to the principal axis, and this ray, after refracting from the lens, it has to pass through the principal focus. We will draw like this. Now we need to draw another ray, and that one again we will take from the tip of the object, and this will pass through the optical center and it will go straight. And where these two rays they meet, our image will form here. In this case, our image will form at this point. So this is location of the image. We can also use arrow for this. So this is our image. We need to label this one using letter I. So this is how we can label. We can also draw small arrows here. So small arrows here. That's all what we need to do for this question. Welcome to A-Level and AP Physics. In this lesson, we will discuss how to sketch optical fiber, prism and glass block ray diagrams for CIE IGCSE Physics by solving tricky past paper questions. For part 1, we need to state the angle of incidence of blue light on the glass. Now, if you look at this figure, angle from horizontal is already given to us. In order to find angle of incidence, we need to draw normal. So this is our normal line. We can find out angle of incidence. Angle of incidence is the angle between this ray and normal. So this is angle of incidence. This total angle means between this vertical line and horizontal is 90. So 90 minus 35. So this angle is 55 degrees. So this is answer for part 1. Simply we can write down this is 55 degrees. For the second part, refractive index of the glass is given. So this is refractive index of the glass. We can simply say this is Ng is given. This is equal to 1.5. But refractive index of air is equal to 1. So these informations we need in order to calculate angle of refraction of light in the glass. Let's say this is medium 1 and this is our second medium. Then we can write down Snell's equation, N1 sine of theta 1 has to be equal to N2 sine of theta 2. In this case, N1 for air, this is equal to 1. Simply we can write down this is 1. And sine of theta 1 is equal to 55 degrees. We can write down here. N2 is equal to 1.5. This is refractive index of glass, and theta 2 we have to find out. We can write down theta 2 has to be equal to sine inverse of sine of 55. So this is sine of 55 divided by 1.5. Simply, if we solve this one, we can find out value of angle of refraction. So that will be equal to 33 degrees. So our answer for this one is 33 degrees. For third part, we need to continue the incident ray until it emerges out of the block. It simply means that until it appears on this side. For that purpose, we need protractor because we need to draw angle of refraction and refracted ray. Angle of refraction is given. We have already calculated. This is equal to 33 degrees. So it means we have to measure angle from vertical, and that has to be equal to 33 degrees. So this angle is 33 degrees. We can use a different color for refracted ray. Let me use the blue one. So this is our refracted ray at angle of 33 degrees. So this is how you can draw. Again, we need to draw normal line. I will be using yellow color for that. So we have to draw the normal line at this point. Little adjust so it looks little better. So this is our second normal line. We need to understand, as this block, this is a rectangular block, and this side of the block and this side, these two sides are parallel. So due to geometry of the shape, our incident ray means this ray, let me use different color for incident ray. So this is our incident ray and emergent ray. These two rays have to be parallel. So we can take our incident ray from here, we can place here. So this is our emergent ray. Incident ray and emergent ray, they must have the same angle from normal and they have to be parallel. That's all what we need to do for this question. But also we need to draw direction of travel of rays. So we can use the small arrows. Now this angle, for example, this is also 55 degrees. We can also label this one. This is also 55 degrees. This question is about optical fiber, and it is based on concept of total internal reflection. Total internal reflection simply means that light will be totally internally reflected, mean it will reflect in the same medium, and light will not be able to escape the medium if angle of incidence is greater than critical angle of the medium. And the second condition is that light has to travel from denser to less dense medium. For this question, we need to draw the reflected rays inside the medium, means inside the fiber. So this is how we can draw normal to this surface. So this is our normal line. Now we need to use protractor to measure the angle of incidence and then angle of reflection. First of all, we need to align over protractor. You can see this is how you need to align this one. Little bit you can adjust. This is how you need to align your protractor with the normal line. Then you need to find out angle of incidence. In this case, angle of incidence is about 64. So angle of reflection also has to be 64. So this is angle of reflection and this is 64, about 64 here. So this is about 64 here. We simply need to draw the reflected ray. So this is how you can draw the reflected ray. We can make it little short so it has to touch the surface. So this is reflected ray. We need to draw another reflected ray because question is asking us to continue ray xy until it passes z, mean it passes this point. For that purpose, we need to draw another normal at this point. means we need to draw the normal line. So this is about 90 degrees. Again, we need to take our protractor and we need to measure angle of incidence. So we need to place our protractor like this. We need to align this one with 90 degrees. We need to find out angle of incidence. In this case, angle of incidence is about 167. So this is about 167, so we can place like this. This is about 168. So angle of reflection also has to be about 168. So it has to be about 168. So this is 168. So we need to draw reflected ray at this point. So this is our reflected ray. We can little bit adjust until it touches the surface of fiber. So at this point it is touching the surface of the fiber. So this is our second reflected ray. Again, we can remove our protractor, but still it is not passing this point Z. So we need to draw another normal at this point. We have to draw another normal. So this is how we can draw the normal at this point, and this angle is about 90 degrees. We need to take our protractor again. We have to place here. We need to align with 90 degrees. This is how we can align. You have to little bit adjust this here. So this is exactly how we can align. We need to find out angle of incidence. Angle of incidence in this case is about 169. So angle of reflection also has to be 169.6. So it has to be 169.6. So this is 169.6. So this is our third reflected ray. We can use blue color and we can draw third reflected ray. So this is our third reflected ray. This is how we can draw reflected rays. But still this is not complete. We need to draw arrows, direction of travel. So this arrow you have to add here, and we need to add arrow here as well. We can also make the normals at dotted lines. So this is our normal. We can make this one as dotted line. We can also make this one dotted line. This is dotted line. This one also dotted line. For this question, a ray of monochromatic red light in air is incident on a glass block at an angle of incidence of 50 degrees. This is what is given to us. You can see here, this is a glass block and angle of incidence of red light is given. This is 50 degrees. For this question, without measuring angles, we need to use a ruler to draw the approximate path of the ray in the glass block and also emerging from the block. Let's try to draw the path of red light, means the refracted ray we need to draw. Look at this one. If there is no change in medium, this light will just go in a straight line. But in this case, there is a change in medium and light is entering into a denser medium. It simply means that the light will bend towards normal. It will bend like this. This is how it will bend. We need to draw another normal at this side, and then we need to draw the emergent ray. So this is our normal at this side. We need to draw emergent ray. Before we draw emergent ray, we need to understand the shape of this block. This is rectangular block and its two sides, this side, they are parallel to each other. It simply means that the emergent ray here and incident ray, these two rays, they will be parallel to each other. We can draw incident ray here, then we can move this one from here to here. So we can make it little short. So this is our emergent ray. It simply means that the angle of emergent means this angle. This is also 50 degrees because this angle is also 50. We can also draw small arrows to show direction of travel of light. So this is how we can draw. small arrows. For part 7b, it is given to us that red light is replaced with violet light. Angle of incidence and glass block, they are the same. Now, first of all, we need to understand which one has higher frequency. Red light has higher frequency, or the violet light, it has higher frequency. Violet light has higher frequency. If the frequency of the light is higher, that light bends more, mean refract more. So in this case, violet light, this will bend more. So this is the key concept, and rest of the steps, they are the same. Based on this concept, let's try to draw the path of violet light. We will use this pink color for violet. So this is refracted ray, means this is bending more. We need to draw normal at this point. This is how we can draw the normal. Again, we need to draw the emergent ray. We need to understand angle of incidence is the same, so angle of emergence also has to be the same. So we will follow the same step. We will draw our incident ray here, and then we will move this one from here to here. So this is our emergent ray. We can also add small arrows. So we can add small arrows to show direction of travel. You can see here these two rays are parallel. Why? Because this is due to geometry of the shape. This question is very similar to the last one. Only difference is that in this case we have this triangular prism, but in the last case we have rectangular glass block. Rest is the same. For this question we have two lights. One is the red one, the other one is a violet light. For the red light, we need to complete the path of the red light. So we need to draw the normal first of all. So at this point we can draw the normal. For normal line we can use green color. So let me draw here. So this is how we can draw the normal on this side. Can make it a little bit short. So this is our normal line. Next we need to draw how this will refract. This will refract away from normal because it is entering less dense medium. This will bend like this. So this ray of light, this is gonna bend like this. So it will bend away from normal. So we can draw like this. So this is what we need to draw for the red light. Now we need to draw for the violet light. Violet has higher frequency, so it means violet will bend more, will refract more. So this will bend like this. Again, at this point we need to draw the normal. So we can draw normal again. We will use green color, so we can draw the normal line. So first of all, let me move this one here. At this point we can draw the normal line here. So let me make it shorter. So this is our normal at this side. Emergent ray, it is entering less dense medium, so it will bend away from normal. This is violet light, so it will even refract more than red, so it will bend somewhat like this. So it will bend somewhat like this. It will bend more than red. So this is how you need to draw red and violet light. We can also use small arrows to show direction of travel. So these arrows are also important. We can draw these arrows here. For this question on figure 7.1, we need to draw carefully without calculation the continuation of the ray through the prism and into the air. But for this question, refractive index of glass is given, that is 1.5, and critical angle for glass air boundary is also given, and this is equal to 42 degrees. In order to draw this incident ray, this is entering at angle of 90. This is parallel to the normal, so this will just go in a straight line. So simply we need to draw this horizontal line. This is what we need to draw. So this is horizontal line we need to draw. Now at this point, this is very important point, because critical angle is 42 degrees. We need to draw the normal line, and then we need to find out angle of incidence. So this is very important point. So let's try to draw normal at this surface. So this is our normal at this surface. We can little adjust this. This is quite good one. So this is our normal. Now we need to find out angle of incidence. Angle of incidence. In order to find angle of incidence, we can rotate this and we can align this one with normal. So over normal. So let me align this. So this is how you need to align. Now we need to find angle of incidence. If you look at this angle of incidence, let me place this one here. So the angle of incidence we can find, so you can see here, this is about 60 degrees. This angle of incidence is 60 degrees and this is greater than the critical angle. So it simply means that the light will be totally internally reflected. The angle of reflection also has to be 60 degrees. So this is how we can draw over reflected rays. So we need to draw here. So this is over reflected ray, but we can make it shorter until this side. Until this side we can make, let me remove this and a little bit extend. So this is our reflected ray. Now we need to draw another normal on this side. So let me draw the line here. So we need to draw another normal on this side. So this is our normal on this side. We need to measure angle of incidence, so you need to align your protractor with normal and then you need to find out angle of incidence. So we can align like this. So we can place our protractor at this point and we can find the angle of incidence for this reflective ray. Angle of incidence in this case, this is about 32 degrees. Angle of incidence is about 32 degrees. Now we need to calculate angle of refraction. Angle of incidence we have already found. This is equal to 32 degrees. And the refractive index of glass means N for glass. This is given in question. That is equal to 1.5. And our next medium, this is air. For air, value of N for air, we can say A. This is equal to 1. Now we need to use Snell's law to calculate angle of refraction. We can simply use Snell's law. According to Snell's law, N1 sine of theta 1 has to be equal to N2 sine of theta 2. In this case, this is our medium 1 and this is our second medium. For medium 1, value of N is equal to 1.5 and angle in medium 1, this is equal to 32 degrees. In second medium, value of N means the refractive index of air, this is equal to 1 and this angle we need to find sine of theta 2. We need to find out theta 2. We can write down this will be equal to sine inverse of, so this is sine inverse of 1.5 times sine of 32 degrees. If we do these calculations, our final answer will be approximately 53 degrees. Simply we need to draw emergent ray at an angle of 50 degrees with this normal. So we need protractor. So let me place our protractor here at this point. Angle of 53 degrees, it means about this. So this is over emergent ray. So this is emergent ray around 53 degrees. This is how we need to draw. Simply we can add small arrows. Let me use different color. Let me use blue one. We can use small arrows to show direction of travel. So these arrows are also very important. So we can simply draw these arrows here.